So today is the 27th of April, all right? So we are going to continue where we left out on last Friday, okay? So last Friday, previous week, we stopped at inferential research, okay?
Yes.
So before I continue on inferential research, I just would like to go back to the overall subject or the overall part of this chapter so that we can better understand what is inferential research. Okay, so you have what we did last week was, okay, you have descriptive research. Okay, this is what we did last week. Okay, so descriptive research is describing only. Okay, so you are describing about the sample, meaning you have how many male, how many female, how many undergraduate, how many diploma holders. Is just numbers to describe only. Okay, so you are not probing the data. Okay, probing means you're not assuming, you're not trying to make sense with the data. You're just describing what the data says. Let's say you go into a hospital and then you just come up with numbers. You say that in this particular ward there are 50 patients with blood group type B, C, or D, whatever. Okay, it's just numbers only. We are not trying to probe anything just yet. Okay, so those are what we say as differential research. Okay, so differential research section needs to be also highlighted in your thesis. Okay, needs to be highlighted in your thesis. Okay, what do we do is in your chapter 4, if I'm not mistaken, where you start talking about your research. Okay, where you start highlighting about your results. Your results. This is where you have to start by introducing. Yes, Sharif.
Saya nak tanya soalan sikit tadi. Regarding on descriptive survey, right? Adakah ianya sama dengan demographic survey for the
Yes,
basically sama, right?
yes, it's demographic lah. Demographic actually, can I say, is one part of descriptive. Demographic kita cuma cakap jumlah.
Assalamualaikum, Doktor.
Waalaikumsalam, Ibu. How are you today?
I'm fine, thank you, Doctor.
Okay.
Sorry to late.
No problem. Okay. Sharif tadi, demographic tadi is basically yes, betul. Demographic is part of descriptive. Okay, but demographic is just more on the number of participants. Okay, so we are talking about the participants, characteristics, undergraduate, male, female, number of male, number of female, number of, but just basically on that. But if you go into detail, like say the number of patients with the blood group type, those are not demographic anymore. Those are just explaining only. Sekadar untuk menyatakan, just to explain sahaja. Okay. At the end of every semester kita buat our pemarkahan. Lepas tu kita tulis how many people got A, how many people got B. Those are descriptive only. Okay, those are descriptive. It's just described only. Okay. Only when we go into the meeting and then we get screwed and then people say, okay, how many people, how many failures? Why did they fail? Now you're going to inferential research. Okay, you're trying to make sense. Kenapa diorang ni fail?
Yeah.
All right. So let's go into. I hope that answered your question.
Yeah, Doctor. Thank you, Doctor.
All right. So inferential analysis. Okay. So when you see the word research analysis, both are talk together lah. You do research, you have to analyze it. Okay. So inferential analysis is deeper and attempts to explain why a phenomenon is the way it is. You want to start explaining. It provides us with the information to understand the very nature, linking factors to the phenomena, and predict. It's also important. Predict the future. takes data. Why we use inferential? Takes the data from sample and makes the inference about the larger population from which the sample was drawn. Okay. All right. So let's focus on these two circles before we go into the title. Okay. Population, kalau you masih ingat lagi, population is the whole. That means if you're staying in a province, the population is the whole, everyone inside that population, inside that province. If that province has 10,000 people, maka your population is 10,000. Or let's say you are looking at the number of lawyers in Malaysia. So daripada atas sampai ke bawah, Sabah Sarawak, the number of lawyers is the population. Okay, that is the population takes in the whole, but the sample can be very small. Okay, let's say we have in Malaysia from top to bottom, Sabah Sarawak included, we have about, let's say, 50,000 lawyers. Daripada itu, sample we want to find out the number of Sharia lawyers. That is possible. Or you make the Sharia lawyer as the population, and maybe you only want to focus on those Sharia lawyers yang buat family issues, or yang buat pasal harta. Okay, so that is the sample. Okay, now let's look at the question. The title. Example of statistical inference. How much does a household spend on house mortgage? Okay, so the question is we want to find out how much does a household spend on house mortgage, meaning to say how much does a person pay for his mortgage, for his housing loan. Okay, so we are trying to see what is the average here. Okay, so the question is the average spending on a house mortgage 30% of the household income? How likely is it that the average spending on house mortgage is more than 30%? Okay, so based on the question, we want to look at what is the average spending. Okay, so now we have a number already lah. Kita bayangkan kita ada number. So let's say the average spending of a person on his house mortgage is, let's say, 2,000. Meaning every month dia akan bayar kepada bank RM2,000. Okay, tetapi, alright, okay, but this RM2,000 ni ialah lebih daripada his 30%. Sebab formula kata, when you take a housing loan, you should always remain at the 30%. Okay, so based on the question, you're trying to infer, and you dapati bahawa people are taking housing loan and they are paying more than what they can afford. Okay, katakan gaji mereka 9,000. Sepatutnya housing loan mereka hanya 3,000 per month. But they are now paying 4,000, 5,000 per month. How likely is the average on this? Yes, Sharif.
Sorry, Doctor, interrupt, Doctor. Sorry. I have a question, Doctor, regarding on statistical inference. Okay, before this, saya ada buatlah kalau based on statistical data kan, dia punya explanation analysis. So saya relate dengan apa information ataupun data yang kita dapat daripada yang kita buat secara kualitatif, which is kita interview juga, informal interview kan. So how about memang kita buat 100% quantitative, statistik lah kan. Kita tak buat langsung interview, informal interview, tak ada buat structure interview. So our statement for statistical inference ni, kita rely pada apa sebenarnya, Doktor? Kita rely kepada data yang kita dapat berdasarkan info yang ada dalam questionnaire tu, ataupun kita relate kita relate dengan of course lah kita akan relate dengan LR kan.
Yes.
Kita relate dengan LR. So maksud saya contohnya macam kita dapat macam Doktor mention tadi, Doktor cakap let's say lah kita dapat 30%, kan, 30%, 40%. So it means that like kita buat summary lah. Before this kan kita ada buat juga macam apa, kita buat apa summary untuk let's say bacat kan, bacat, dan then kita akan buat fluctuations dia punya chart from year to 2010, let's say. Macam tu ke cara kita buat inference kalau untuk purely quantitative?
Yes, exactly. That means if you are doing purely quantitative, maka you rely on your data. Your data is the supporting factor. Okay, your data is the supporting factor. There is no need for you to do there is no need for you to do mixed method lah. Maksud dia, kalau data itu kuantitatif, you dah dapat numbers tu, tidak perlu you buat kualitatif lagi. It's okay, no problem. Why do people do mixed method? Hanya untuk make it stronger. That means to prove that what you have in your data is the same as what is being being said again. For example, let's say we interview these people yang bayar housing loan, kan? So among the questions yang kita akan ditanya is, how much are you paying for your housing loan? Okay? Let's say you kata I'm paying 3,000. Ibu kata I'm paying 2,000. I tell you, I am answering the survey. I'm saying I'm paying 5,000. Okay, alright. So you get the data, and then you analyze the data, and then you dapati bahawa a lot of these people are paying more than 30% lah. Okay, more than 30%. Okay, so dah betul lah tu. You can conclude your research dah. You have got the idea. Right? If you want to make it, you want to make your argument stronger.
Yeah.
Then you can do a qualitative research. You can do macam saya explain last week, focus group, or you can interview. Okay, you can interview. Maybe this time you jangan interview. You can interview the same person. Oh, sorry, you can't interview the same person. You can interview, let's say, the bank manager. Tanya bank manager, kenapa orang ambil, or how many people in a year will take at least about 30% of their gaji, they'll pay 30% ke. So now you can conclude the answer. Whatever you found in your data, sama juga dengan which was explained by the bank manager. So it's okay. Tidak, Syarif, you don't worry. Tak semestinya your research memerlukan mixed method.
Okay.
Normally, we use mixed method kalau lah area itu sangat baru, it's a new area, and there isn't enough evidence to support your idea. That means, what do I mean by that? That means yang you dapat itu, evidence you dapat from survey tu very 50-50, macam not balanced enough lah. Then there is a need for you to do mixed method. Tetapi mixed method pun adalah dia punya, orang kata, kerenah dia. It's not that easy juga lah. I mean, you have to set up what kind of mixed method you want to do and so on and so forth. Okay? Alright, so again, now we go back here. So, descriptive dah tahu. Inferential. Kenapa dia pakai ayat? Dia kata use to generalize about the population based on the sample. What does that mean? That means in a province there are 10,000 people. So you buat satu study. But it's impossible for you to get 10,000 people. So you get a sample. Sample yang jawapan ini boleh generalize the public. Okay? So we can generalize the public. Secara keseluruhannya, kalau dalam bahasa Melayu dipanggil secara keseluruhannya, like that. That means, like say for example, results A level. Katakan in Malaysia ada about 2,000 students, and kita ambil satu sampel. Okay, and then we can say yes, secara keseluruhannya student-student yang ambil A level pada tahun 2022 mendapat kepujian and so and so. But then again, kadang-kadang I think you can agree with me at this. When we see the news, kerajaan kata macam ni, But we see it's not right, it's not generalizing enough. Sebab sampel yang kita ambil itu, it's not generalized. That means, what do you say? Let's say you want to find out daripada population dalam province tu, you want to find out a sample. But sample you ambil semua orang kaya. So kalau you ambil sampel orang kaya, then your answer is cannot be generalized. Ataupun you nak study peratus kelulusan matematik di Malaysia. Okay? So jumlah pada tingkatan 5. Jumlah student katakan dalam 20,000. But you ambil sekolah yang pandai je. Or sekolah yang kawasan bandar je. So memanglah secara based on numbers you can generalize. Tapi your answers cannot be generalized because it's not a good pool, kata. You ambil situ je. Sepatutnya kalau you nak ambil a good generalization, you can ambil sedikit daripada kawasan luar bandar, sedikit daripada sini, sedikit daripada sini. Alright? So inferential statistic or you are trying to refer balik pada population. So that's why sometimes when they say yes, we have done a study, kita ambil sampel daripada population 10,000 and we find out that rakyat Malaysia semua kaya-kaya. Yalah, kalau you study rakyat Malaysia di Damansara memanglah kaya-kaya, right? But if you take a good population, mungkin daripada 5 orang daripada sini, or 10% from here, 10% from kawasan luar bandar, then you'll get a good answer. Alright? So inferential, we measure the heart rate of each student walking class and then announce 95 that we are 95% confident that the heart rate of the students who walk regularly is between X and Y. Okay? So this is inference. Okay, so now population kat sini. Consists of all items, elements of interest for a particular decision or investigation. Example, all married staff over the age of 30 in UiT and Perak. Alright? All married staff over the age of 30 in Kampung XYZ. Okay. Now, you go in to get your sample. Certain number of elements that has been chosen from the population. Example, a list of all married men and married staff over 30 in FSPU. FSPU is a department lah. Okay. So population, semua. A list, all married men in Kampung XYZ. Okay, so you get a number. That's your population. Or make. Sample is all married men over the age of 30 from Kampung XYZ that has who got married in year so and so, or who got married in the year between so and so. Alright, so we want to go down to the population sample. Alright, so what kind of type of data that you can collect? Nominal, ordinal, ratio. So this you have to not memorize, but you have to understand this. You can do it weekly. That means you ask questions. Example of questions. In 1 week, how many times do you refer to your boss who is in another country? In 1 week, how many times in 24 hours, in 1 day, how many times do you look at your Facebook? In 1 day, how many times do you look at TikTok? Macam tu. 1 time, 2 times, 3 times, 5 times, 10 times. Okay. Ordinal reflects the grade. Maksudnya kita bagi grade lah. Okay. Between this number and this number, what is the grade? So respondent akan pilih. Okay. Akan pilih what number they are in. Ratio is the number itself. How many years have you been working with University Y? 15 years. Okay. Kalau soalan yang sama dalam bentuk ordinal, we say, how many years have you been working in University A? 1 to 5, 6 to 10, 11 to 15. So kita pilih je ratio. Kita pilih je. So responden akan pilih. Kalau ratio is the, how many years have you been working? 5 years, 10 years, 15 years. Okay, dah. The number is there. Okay. Kalau nominal, dia based on categorical data. In 1 week, soalan dia biasa macam ni. In 1 week, how many times do you exercise? Macam tu. Kalau nominal and ordinal campur, in 1 week, how many times do you exercise? 1 to 5, 6 to 10, 11 to something. Alright? But we are not worried dia buat exercise tu mungkin 1 hari 2 kali pun tak kisahlah. Tapi kita nak tahu, in a week tu berapa? Let's say you have the question of nominal and campur ratio. In 1 week, how many times do you exercise? Dah. 5 times? 4 times? 0 times? Maybe, tak ada, maybe lah. Okay. Or maybe we ask the question, during fasting month, how many times do you exercise? None. Macam tu lah. Okay. Okay, this is descriptive research, how it looks like. Okay, now we go into a bit more details about the term called variable, the term called dependent variable, control variable. Let me just show you if I have a picture here first. Okay. Okay, before we go back into the, before we patah balik kepada explanation, let me just show you this picture. So from this picture, you will understand better. This picture was taken from my daughter's science book. Ibu, in Malaysia now, science darjah 4, I think. Darjah 4 is dalam 9 tahun, mereka sudah belajar ini.
Oh.
Mereka sudah belajar dependent variable. Mereka sudah belajar independent variable.
Yeah.
So, saya besar panjang baru belajar. Okay, let's do this. Okay, let's look at the plan here. So, independent variable, variable that is changed, bertukar. So, dalam case dalam gambar rajah ini, the amount of water changes. So, berubah. So, kita boleh predict dalam kepala kita, mungkin lagi banyak water, lagi pokok tu akan berkembang. Okay. Dependent variable is affected by the change. The size of the plant, the number of leaves, living or dead. So it's dependent. Okay. So independent is something yang berubah. So how does this diagram on the left relate to this? Lagi banyak air diisi, lagi besar pokoknya, lagi banyak daunnya, and dia akan hidup lah. Okay. So this is the example first. Ini example paling senang. Okay. So obviously lah, independent. So benda tu berubah. So maybe you can say kalau kita relatekan balik kepada ourselves, the more you exercise, okay, the more you lose weight, for example. The more you fast, the more you will lose weight. The more you do something, the more you eat less. Okay, so independent variable can be a few. Okay, Sharif, can you give me one example of an independent variable dalam example pokok ni? Selain pada air, apa lagi independent? Sorry, not independent. Independent. Sorry, yes. Can you give me an example of another example of an independent variable dalam example pokok ni?
Lighting.
Lighting. Apa lagi?
Location.
How about baja?
Ya, fertilizer.
Fertilizer.
Yeah, fertilizer.
Lagi banyak fertilizer kita tambah, dia mungkin lagi lah. Kita tak boleh, betul juga. Lagi banyak kita tambah, saiz pokok mungkin naik, daun mungkin lebat, ataupun kalau dah terlalu banyak fertilizer, pokok tu mungkin mati.
Ya. Size pot, size pasu.
Saiz
lagi
pasu.
besar. Ya.
Okay. So these are all changing. And these changes will affect something else.
Ya.
Alright. Okay. So it's also here, sir. The amount of water, fertilizer, semua ada kat sini. Okay. So now you can get the idea. Now you go back to the definition tadi. Okay. Variable meaning any factor that can have an effect in the experiment. Okay. Any factor. Independent variable, what is being changed? Independent, macam tadi lah. Fertilizer, air, so on. Benda tu berubah. Dependent variable is what is being tested or measured. Okay, losing weight, so that is being measured. How do you lose weight? You use an independent variable. You exercise lebih, puasa, so that is it. Control variable pula, these are the things that you keep the same and don't change during the experiment. Control variable. Example, kalau kita pergi pada pokok, the control variable could be pokok yang sama berada di lokasi yang sama. Beberapa pokok berada di lokasi yang sama, meaning in the same room, same temperature, same sunlight. So these are all control variables. Okay. Maybe if let's say you relate back to your sample size, that means the control variable is type of student. Where does the student come from? Kampung tak kampung. So you keep that. So that means your sample is the same because these things you control. Okay. So dependent variables whose values you wish to predict is also called the response, the outcome. You want to predict how much you will lose weight. How much will you lose weight? Okay. So losing weight is what we say is a dependent variable kerana ia bergantung kepada something else. Okay. Your weight is depending on something else. The more you eat, lagi besar lah you. The less you eat, or the less you the less you eat, the less you exercise, the less you fast, lagi besar lah you. Okay, so that's dependent. Independent ialah what effects that dependent tadi tu. Okay, what effects that? It's called either the exploratory, the predictors, the risk variable. Exercising, fasting, apa lagi? Eating less. So these are all predictors. Okay. A variable in a research simply refers to a person, place, thing, phenomenon that you are trying to measure. Okay. Example of dependent is depression symptom, which depends on the independent type of therapy. Okay, type of therapy. So the type of therapy can change. So kalau seseorang itu is under depression, so the type of therapy changes. Okay. In an experiment, researcher is looking for the possible effect on the dependent variable that might cause changing the independent variable. That means if you change the independent variable, something will happen to your dependent variable. You bagi banyak air, then your pokok will become bigger. So classification of variables. So we have two kinds of research study. I told you we have qualitative, quantitative. And in quantitative, we are looking for interval and ratio data. Okay. So as you can see here, the arrow here, it's more informative. Okay, more informative. So you can get more information from your data. All right. So these are certain examples. Right. Okay. So is it
Slide
moving?
remain yes.
Kejap. Okay, is the slide moving now? Is the slide moving now? Boleh? Let me see whether the slides are okay now. Okay, now can you see? Okay. Okay, Tanya, can you see it? Okay. All right. So now we continue dengan this slide here. So what we're trying to look at is, okay, we are trying to look at numerical data, which is over here, okay, on the right hand side. Okay, so today we are focusing on the descriptive analysis for numerical data. Okay, so you can do in two formats. If you are doing descriptive analysis statistics, you can do for categorical data, and what have I presented here is what kind of analysis you can perform. So in this, on the right hand side is for descriptive statistics for numerical data, and these are what you can do. This is how you can measure them. Okay, central tendency is measures of central tendency are numbers that tend to cluster around the middle. Okay, cluster around the middle. So we are looking at mean, median, mode lah. Okay, this is normal. This is quite simple for you. When you do any statistical analysis, you count the mean, the median, and the mode. Okay, so this is very straightforward.
Okay.
Okay. Next, next we look at dispersion over here. Okay, dispersion is how the data is spread out or dispersed from the mean. The smaller the dispersion value, the more consistent the data is. Okay, the larger the dispersion value, the more spread out the data are. This means the data is not consistent. Okay, so how do you measure dispersion? You can do it through range. Yes, Sharif.
Saya tak tahu ni, saya punya line ke?
Ibu, can you see my slides?
Not see.
Dia macam punya explanation memang takut-takut lengkap. Discord dekat
Yeah.
nah.
Okay. Oh, it's okay.
Sharif, what can you see now? Okay, is this okay? Is this better?
I think okay. Tapi itulah kalau try doktor cakap dulu ni dengan suara doktor. Kalau tengok grafik okay.
Testing.
Yeah,
Okay.
okay,
Okay,
Doctor. Okay,
right.
okay.
Okay, dispersion. Okay, so now I'm in the slide of dispersion. What does dispersion? Where is dispersion? Okay, so dispersion dekat sini, here, this part here. Okay, so again, let's come back to this slide. What is this slide trying to explain? This slide is trying to explain if you are doing descriptive statistic, descriptive analysis, these are the examples of analysis that you can perform. Okay, and the analysis that you can perform depends on the type of variable yang you ambil. If you are doing ratio variable, maka you can do these four types of measurement or four types of analysis. If you are doing categorical variable, maka you can do these four here. So let's look at central tendency under ratio variables. So central tendency means you're only merely getting the mean, mode and median. Senang je. Very straightforward. Okay, straightforward. Dispersion, you want to see if how much dispersed is your data. The smaller dispersion, the more consistent the data is. Example, let's say you are taking the number of students, male, age 15 in a particular area. So you want to see the data is dispersed, but not too dispersed. So the data has to be, the number of the dispersion value needs to be small, meaning it's consistent. Bukannya, okay, the data is not consistent. So let's see how do we measure this consistency. In order for you to measure consistency, dispersion, four methods have been suggested: range, interquartile range, variance, and standard deviation. Okay, so you want to see the dispersion in your data. Bukannya semua pandai, bukannya semua kurang pandai. That means you want to get students yang semua sama. Ada beberapa yang pandai, ada beberapa yang kurang pandai, ada beberapa yang average. So you get a good dispersion. Or maybe you look at the quartile. That means keluarga daripada pendapatan rendah berapa student, keluarga daripada pendapatan tinggi berapa student. So you get a range kat situ, interquartile range. Okay, variance, mean of squared deviation scores about the mean. Okay, so he's looking at the mean kat situ. And the standard deviation is the square root. Okay, example kat sini, range. The simplest measure of dispersion and is obtained by taking the difference between the large value and the small value. Okay, so if you're studying, let's say you want to study the exam marks for students. So you get the highest and you get the lowest and you you minus, so that is your range. Interquartile daripada mean tu, daripada median, how many people are, what is the dispersion kat situ. Okay, so interquartile means a measure of variability based on dividing a data set into quartiles. Maka kita divide lah. So let's say we have 50 students. So we divide it according to quartile. Be lower income, higher income, middle class, macam tu. Alright? And then based on that, kita tengok how many students are in each of this. Interquartile, where do we use them? Some companies use quartiles to benchmark other companies. Example, the median company salary for a given position is set as the first quartile of the top 20 companies. Okay. What does this mean? Why do you use interquartile? So Alan dia, where do you use them? So you use interquartile kalau you nak tengok what is the average lebih kurang lah. What is everyone paying? Let's say executive in a bank. He might be paid 5,000, he might be paid 10,000, but he should be within the quartile kat sini. Mesti berada di sini. Mungkin tak sama lah. Mungkin bank A and bank B is not the same, but is within that area. Let's say a person is working in the factory, right? So he or she earns about 5,000. But another company, another factory, the workers there earn 4,000. Okay, it's within that same quartile, or should be less, or should be more within that same area. Okay, all right. Example number 1 again. Consider the following data sets of two age group. Company A, inilah age group dia. Ada 47, ada 38 dalam company tu. Ada beberapa orang dalam department tu, ada, this is the age. 47, 38, 35, 40, 36, 45, 39. Company B pula ada banyak age. Okay. So the mean workers for is same. So kalau kita tengok purata dia sama, 40. By knowing the mean age, it can be deduced that the workers' age distribution is the same. Okay. However, the variance workers is very different from two companies. Company B has much larger variance than the age of company A. Nampak ni? Tiba-tiba ada 70, tiba-tiba ada 18 kat sini. Company A pula semua lebih kurang sama. Okay, the variance is okay. Alright, even though yes, the mean is the same, but the variance, we are looking at the variance. Okay, let's say for example, two courses. In two, you are teaching. Sharim is teaching the same course. I'm also teaching the same course. Both of us have 10 students, but my students cost 50, 60, 50, 60. Sharim students cost 100, 90, 190, 0, 20, 20, 20. When we both compare, purata kita sama. But that does not mean the variation is the same. Because he has a few hundreds. I only have 30, 50, 30, 50. Okay? So the dispersion is not equal kat sini. It should be equal. Tak boleh pandai, tak boleh kurang pandai. It should be equally justified. Alright, so this is another example. In this city, the mean and median of family income is 25,000 per year, and zero variation as every family has income exactly 25,000 per year. City Y pula, a different city, okay, a different city, has the same mean and median, but 95 of the families have income 12,000 per year and 5% have 30,000 per year. City X is perfect family equality, whereas there is a great family income inequality in City Y. You understand this? Faham tak ini, Ibu? Dua bandar berbeza. Okay. Sharim, do you get this example?
Ya,
Okay.
boleh.
Boleh ya? So even though we say that dua-dua bandar ini is getting the same 25,000, tetapi in city Y there is a big difference. Yang kaya sangat kaya, yang below tu is jauh. But kalau kita tambahkan, you get the same mean, same purata. Alright, standard deviation. What is standard deviation? Is based on the mean and gives an average distance between the scores. Okay. Correlation. This is very nice. Correlation. Let me see. Wait. Sorry ya, sekejap. Describes the strength and direction of the linear relationship between two variables. Example of variable, Let's think. Fasting and exercising. So we want to, when we talk about the relationship and the strength, we need to talk about two variables. So in this example, I'm saying that fasting and losing weight. So fasting is also a variable, and losing weight is also, fasting is a variable and losing weight is a variable. Okay, so we want to see what is the relationship between two. So there are two methods in how you can do correlation. You can use Pearson product moment, or you can use Spearman rank. These are the two methods. Okay, all right. What do you measure in correlation? A correlation coefficient is used to measure the...
Doctor,
Yes.
sorry Doctor.
Yeah.
Sorry Doctor, yang previous slide tadi, can Doctor explain
Okay, sorry.
for Spearman tadi?
Okay.
Saya yang ni first time saya jumpa Doctor, sorry yang ni.
No problem. Okay.
Okay.
There are two types of data yang kita explain, we are talking about in this whole chapter. One is a discrete, one is continuous. There are two types of data lah in this chapter. And these two types of data are frequently used in quantitative study. So they are discrete and continuous. Obviously lah, kita tengok continuous bermaksud continuous. That means you take it regularly, continuous. Contohnya temperature kat sini, running, kita lari, you ambil continuous. Ini yang example number 2 ni, dia ambil gambar dalam filem, or you exercise. These are continuous. You have to do it daily. Okay? Discrete is sekali. The age, once. The number of times you eat in a day, once. That's it. It is not continuous. Okay? Shoe size. Okay? So this example, why do I show you this? Why do I give you an example of continuous and discrete? This is very important because you need to understand from this discrete variable atau continuous variable, this is where you will define what kind of measurement analysis you want to use them. Okay? How you are going to measure the correlation between this. Example. Kita ambil example yang senang. Losing weight and exercising. So exercising memang by default is continuous. Senang lah. Memang continuous. Sebab you have to do it continuously. Continuously. Loss of weight is what we say is discrete variable because there's a number for it. Kalau you lose weight lah. What is your weight? 50, 60, 70. Kalau continuous variable, you have to continuously exercise lah. Maka soalan-soalan dia berbentuk, in 1 week, how many times do you exercise? What is your regular exercise? What is your exercise routine like? Do you do a lot of cardio? Do you do a lot of this kind of exercise? So soalan-soalan berkisar macam ni. Okay? So based on this, we want to determine our correlation tadi tu. Correlation coefficient. Okay? What is the meaning of correlation? Measure the strength, kekuatan di antara variable ini dan ini. Want to see what is the strength. Example, losing weight tadi lah. Exercising, losing weight. Kedua-duanya ialah variable. But what is the relationship? Are we saying the more you exercise, the more you lose weight? Or are we saying the more you exercise, the less you lose weight? Or are we saying the more you exercise and fasting, the more you lose weight? Boleh juga. Okay, it can be in so many ways. Alright, so coefficient ini to find out, is it a positive coefficient or is it a negative coefficient? Why do we need to know a negative or positive? Kalau dia ni positif, maka dia betul lah. Lagi banyak kita exercise, lagi banyak kita lose weight. That is what we say as a positive coefficient. A negative coefficient is less. The less we eat or the more we eat, the less we lose weight. Okay, coefficient means antara salah satu variable, ianya ialah negatif. Kalau coefficient positif, kedua-duanya positif. The more you exercise, the more you lose weight. Okay, maybe you have seen dalam journal yang mengatakan bahawa there is a positive impact, there is a positive relationship. Itu semua, it's a positive coefficient lah. But they don't know. Dia cuma cakap, the hypothesis says there is a positive relationship between exercising and losing weight. Tetapi berapa persen? You kena kaji lah. Because we want to tell the readers, we want to tell people, kalau you exercise 5 kali seminggu, you will lose weight. But before that, I know, you can explain, you kata, there is a positive relationship. Kalau saya tanya Syaril, how do you know there is a positive relationship? You tak buat study ni lagi. Based on my research, based on my readings, I find that previous studies have stated that there is a positive relationship between exercising and losing weight. So selepas itu, you buatlah study you. And then you find out the coefficient is good. There is a positive coefficient. Ini membawa kepada, yes, there is or we say, it is supported lah. Exercising is to lose weight. Okay? So, how do you analyze this? You can use the Pearson-R relationship. How strong is it? Okay? So, kalau dia punya range, jawapan dia ialah between -1 and +1. Kalau dia -1, meaning, tak ada apa-apa, there is no relationship. You exercise lah banyak mana, memang tak ada. You puasa lah banyak mana, tak ada apa-apa. Not losing weight. Okay? For example, height and weight are positively correlated sebab taller people usually weigh more. Okay? Ini dalam journal lah. Okay? Dia kata, taller people, height and weight are positively correlated. Ada kesamaan di situ kerana taller people, orang yang lagi tinggi, okay, weigh more, lagi berat. Ibu, are you thinking of buka puasa? Okay.
No, doctor.
No. Okay, let's look at the last point here. For example, age and hours slept per night are negatively correlated because older people usually sleep fewer hours per night. So they are is negative correlated. Okay, it's negative. So when we say it's negatively correlated, it means there is no relationship. Okay, positive means yes, there is a relationship. But adakah apa yang kita kata ni salah? Tidak. Whether it's a negative relationship or a positive coefficient, both are acceptable because you have proven that there is no relationship. Although you baca dalam journal, you dapati bahawa there is a relationship, tapi bila you survey, tak ada rupanya. Okay, fine, tak ada. Maka, it's not to say that the journals are wrong. No. The journals are correct. But maybe you found something new. Boleh juga jadi macam tu. Okay, steps of doing correlation ada beberapa step lah. Okay, this one you can read on your own and you can find out. Okay, so as you see here, correlation value is between these. This is very important, -1 to +1. So your jawapan bila you buat correlation, you will see the answers will be like this: 0.9, 0.5, 0, negative, negative. Okay, so you get this. Tapi anyhow, anyway, jawapannya harus berada dalam -1, +1. So as you can see here, kenapa dia kata this is a positive strong, but this is also strong? Why is it like that? It could be, you have to interpret it in this way. The more you exercise, the more you lose weight. Betul. So that's a strong relationship. In the other way around, you get a negative relationship. That means it's negatively totally not right. It's so strong that it's negatively not right. Macam tu. A weak relationship, it could be kadang-kadang terjadi, kadang-kadang tak terjadi. Okay. It is okay. We can do all this. Okay, and then we also look at p-value. So bila you dah dapat your R value kat sini, you are also going to get your p-value. Okay, question. Saya cakap pasal R value, p-value ni tang mana? Where do you get all this? Where do I get all this? Sorry, I forgot to mention. You get it from your SPSS. SPSS will do it for you. Okay, SPSS will do it for you. Okay, you put in everything, it will give you. Cuma, your job is to interpret those values. Okay, so in coefficient, you also will get the p-value, the significance value. P-value is the probability that we would have seen our data or something more unexpected just by chance if the null hypothesis is true. So what does that mean? It means kalau you dapat R value you tinggi 0.9 tetapi P value itu insignificant, that means that although there is a strong relationship between two variables, but it is insignificant because the data that you got could be, it is not, orang kata, not well distributed. Itu. It could be not well distributed. Maka it is not insignificant. So when it's insignificant, we can also reject the hypothesis. Bila you nak accept a hypothesis, hypothesis Syarif mengatakan bahawa the more we fast, the more we lose weight. Itu Syarif punya hypothesis. So he does the research, he gets the value, masuk SPSS, he gets the R value of 0.9, meaning there is a strong relationship. But bila they check, P value is at less or is greater than 0.05. It's not significant, it's insignificant. What does that mean? It shows that Sharin's hypothesis is not supported. Kenapa not supported? Because his p-value is insignificant. Why is it insignificant? It could be his data, the people answering his data didn't answer it well. That means semua jawapan yes, or semua jawapan no, semua jawapan kat tengah-tengah. Dia tak jawab secara truthfully. Okay? Semua jawapan dia betul. Tapi bila tanya orang, do you fast? Semua cakap yes. Tak ada orang yang cakap tak puasa. Or semua cakap makan banyak tu je. Semua cakap, okay, it's very straightforward. Okay? It's very straightforward. That means everyone is doing right. So it's insignificant. Are you with me? Okay? Let's stop for a short break. And oh yeah, Syarif, your question first, and then we go for break.
Sorry doktor. Saya ada satu persoalan lah berkaitan dengan for those yang answer true semua ataupun answer no for the all questions. Adakah data tu perlu kita masukkan dalam kita punya we have to table out our finding on that?
Yeah.
Ataupun kita it's not valid which is kita kena dapatkan balik.
Well, depending on the number lah, the number of macam, kalau setakat you get 100 respondents, daripada 100 respondents tu, ada beberapa lah, beberapa yang macam tu, then yes, Kalau dah data you tak cukup, let's say you only have 100, dah tak boleh dah, then you masukkan saja. But if you have a lots of data, then data-data macam yang Syahrin kata tadi, you have to throw it out.
Okay.
You kena buang. To keep your data clean, that's how we say clean. But if you cannot keep it clean, in sense of macam you don't have enough data, then you can keep it juga. Boleh, tak masalah. You can keep it.
Okay. So itu yang dapat tadi tu, yang dapat P tadi tu, yang dapat apa yang Dr. mention tadi tu.
Yeah,
So, okay. Okay. Okay, Doktor.
the insignificance tu. Because it's already positive, tapi not significant. Contohnya macam ni lah. How do you make sense of it? Let's say you you kata, ya betul, cycling loses weight. So you find a positive relationship, betul. Tapi you tengok, tapi this is not significant sebab semua yang you interview, semua cyclist. Yang memang sejak azali dah memang cycle. So memang they like cycling. So you have to interview or you have to get respondent yang baru nak cycle, yang memang berjinak-jinak dengan basikal untuk lose weight. If you interview cyclists yang memang into bicycle, memang you'll get a positive relationship. But you'll be insignificant. Sebab if you ask them in 1 week how many times you exercise, in 1 week how many times you cycle, memang they'll answer 10 times, 20 times. So that is insignificant lah, because you are asking a person yang memang suka benda tu. Okay? If you go to a restaurant, if you interview the customers, do you like eating burger? If you interview a person who memang azali dia likes burger, then it's insignificant lah. You have to ask the people yang jarang-jarang datang, sekali-sekala datang. That is the significant value kat situ. Okay, alright, let's stop for a bit. We will continue back in about, actually we can just finish up. There's only about 4 more slides, boleh Kejap je.
Ya, boleh.
Sebenarnya tak ada apa-apa pun, okay. This is frequency table. Okay, so frequency table macam ni lah frequency Okay, so this is an example of I'm doing a survey and I got 100 smartphone users. So these are their brand. Apple, Samsung, Motorola, Vivo, others. Inilah semua dia. And based on the frequency, I because this is descriptive analysis so I got their brand lah. Okay, this is their brand. Okay. Alright. And then you can also do cross tabulation. Okay. Example, sales of an electrical company based on their zone. Okay, kalau zone utara, berapa banyak sales dia. Okay. And kita bagikan based on product. Contohnya, microwave is sold better in KL and sold less in Kelantan. Okay, so that is what it means by cross tabulation. They always use this cross tabulation macam process vaccination. Vaccine in KL berapa, vaccine in Kelantan berapa, based on cross tabulation. Okay, alright. So what have we discussed so far? We have looked at descriptive research. We have also looked at how to analyze descriptive research. We have also looked at correlation, coefficient, and based on that, we have also touched a little bit on inferential statistics as well. Okay, so we'll have a short break and then we'll continue after this. The time now is 6:06. We will start back dalam 6:15 lah, 6:15. Okay, Ibu? 6:15
Okay, Doctor.
Alright, so we are now back. Okay. What we are going to do now is we are going to look at univariate analysis. Okay, univariate analysis. Right? So what is univariate analysis? When you talk about univariate, maksud satu lah. We're only talking about one analysis. That means one dependent variable. Okay, one dependent variable. Is descriptive juga, tetapi we are looking at one dependent variable. Okay, independent can be banyak, tak kisah. Okay, can be one also, can be many, but the dependent part yang we are looking at here. Okay, so what is univariate and bivariate? Univariate, you might study a group of UITM students to find out their average MOIC scores. Okay, so ini Ibu, what we're saying is you want to know only one item only on the dependent side. Okay, if you're looking at bivariant, you're looking at, okay, obviously two. Again, you're looking at the dependent side. When you're studying two variables, you might study a group of diabetic patients to find out their weight. Okay, so ada dua variable di sini. Alright, so univariant and bivariant. So now we go on into independent variable tadi. Okay, so we know what is independent variable. What is univariate analysis? So when we talk about univariate analysis, we have to refer back to our independent and dependent variable. Okay, as I explained to you, independent variable is variable that changes, yang bertukar. Example of common independent variables are gender, okay, independent. Okay, so you can control them or you can change them. Okay, all right. So now let's see to dependent. Dependent tadi macam ni lah. Depression. Dependent variable is depression. The independent is type of therapy. So univariate analysis, an example. If you look at the right hand side, it's all one variable. Blood pressure, BMI, cholesterol level. Okay? Okay, let's pause for a moment. Look at the dependent variable. As you can see, the dependent variable are all measurable. What does it mean by measurable? Boleh diukur. You can measure them. Blood pressure, boleh. Ada numbers dia kat situ. BMI, ada numbers dia kat situ. Cholesterol level, yes, high, low, ada numbers dia kat situ. Okay? So this is also another factor kat sini. You have to get it right. So when you do the naming for your dependent variable, you have to do it. Sorry, you have to name it so that it's measurable. Boleh diukur. Frequency. Okay, frequency is measurable. Performance is measurable. Heart rate, heartbeat is measurable. So dependent variable must be boleh diukur. Must be betul? What do we say? Can be. You can measure it. I'm sorry. Do you all get this slide? Did I put it in the WhatsApp tadi?
Yes, Doctor. Saya dapat.
Okay.
Downloaded.
Now go back to independent. Salt intake, exercise frequency, fat content. Again, this slide is talking about univariant. So univariant hanya melihat kepada dependent satu saja. But independent boleh banyak. Tapi in this diagram saya buat satu lah. But again, look here. Intake, frequency, fat content pun boleh diukur. Is measurable. So, what do we know from this slide? Whenever you draw a diagram, make sure your variable name is measurable. Boleh diukur. Tidak kira lah you're doing on your independent or your dependent, but when you do the names for your analysis, untuk your hypothesis, it should be measurable. Boleh diukur. Okay, this we have covered this now. Right, so where are we now? We are quantitative data analysis. Okay, so sebelum we start, anytime you nak buat your analysis, you first have to identify what is your dependent variable. Let's say your topic of interest is knowledge sharing among HR executives in companies. Okay, knowledge sharing between human resource executives in a company. Right? So first you have to determine your dependent variable. Next, data type tu. What type of data are you looking at? Is it categorical, numerical, ratio, okay, ordinal, semua tu. And then based on this type of data, you are going to do descriptive first. And then you do inferential. Okay. Inferential tadi tu macam I give you an example. You can do your Pearson relationship. Okay. You can do your coefficient, correlation coefficient. That comes under inferential statistics. Kalau you buat center tendency, mean, mode, median, yang simple itu comes under descriptive analysis. Frequency table, descriptive analysis. Next, determine what type of research you want to do. Sorry, what type of analysis you want to do. On the left hand side, descriptive ke? We have explained about this in the previous chapter. Kalau buat descriptive, these are examples of the analysis that you can do. Kalau you buat pasal inferential, then these are the examples of examples of analysis you can do. Chi-square, t-test, one-way ANOVA, z-test, simple linear regression. However, do not feel that saya kena buat semua ni. Tak. You don't have to do all, tidak perlu. You just choose which is necessary sahaja. But normally, kebiasaannya, everyone will do number 5. Linear regression, you akan buat. You nak find the coefficient, correlation coefficient, you will do regression. Kan, tadi kita ada R value kan. R value is to find out your coefficient. It should be between -1 and 1. That means we want to see how strong is the independent variable towards the dependent variable. Chi-square, t-test, one-way ANOVA, this is all depending on the type of research you are doing. Chi-square determines whether there is an association between categorical variable to measure the difference between what is observed and what is expected. Okay? So here, the important point here is we do chi-square if our data are independent, are categorical. Then there is a need for doing chi-square. Why do we do this test? Because we want to find support for our hypothesis. Example of a chi-square. So the example here, the question is measuring the height and weight about the population of residents in Sri Iskandar. Okay, so Ibu Sri Iskandar is a taman lah in our area. Alright, so this is the population dalam taman tu. So daripada taman tu saya ambil sampel dia. And then I do a variable, I do a survey here lah. Okay, I do a survey here. And I do the descriptive analysis here. So I do categorical, I summarize berapa jumlah male, berapa jumlah female, and I visualize them, buat dalam bentuk graph. I buat numerical, I buat the range kat sini, everything is here. Okay, and then I want to do more inferential. I buat chi-square macam mana rupanya. I buat t-test macam mana rupanya. I buat correlation macam mana rupanya. As you can see here, correlation is the simplest form. Because we want to measure the height and weight about the population. So I want to see between the height and weight, what is the correlation? Adakah kita kata lagi tinggi orang itu, lagi besar? Or are we saying the reverse? The shorter the person, the less weight he or she is. So we do inferential analysis. So all of you have to do descriptive and also inferential. Memang kena buat. Okay, inferential. Memang you kena buat. Sekurang-kurangnya you have to do the correlation kat sini. Yang whether you do ANOVA, t-test, chi-square, it depends on the type of data you are studying and what are you looking at? Okay. Right. Measuring the height and weight about the population. Does the proportion of male and females differ across age group? So we say hypothesis 0, null hypothesis is gender does not depend on age. Gender depends on age. So we look here, kat sini. So adakah the gender and the age are the same? Is there something going on? So we are trying to see, is there something between the gender and the age? Are we trying to say age yang lagi tinggi semua perempuan or age yang lagi rendah semua lelaki? So these are examples of research that you can do. Alright, we can also do t-test. Okay, t-test dah T kat situ. What does T mean? T means time. If you're studying one group, use PET t-test to compare the group mean over time. Setelah selang masa. Senang je. T-test means over time. Awal semester, akhir semester. Awal tahun, akhir tahun. 6 months pun boleh. First month, 6 months later. Okay. So you want example. Sample 1, female staff age 13 and above in this department. After 6 months, berapa pula? Okay. Let's say student is studying online. So you want to see the effect over 6 months. So you buat t-test at the first month. Sorry, you get data first month and you get data 6 months later. And then you buat a t-test. So T kat sini bermaksud time lah. So when you do a t-test, you're looking at over time, over a period of time. Okay. So this is also an example. Is there any height difference? Average over a period of time. So you see lah what is the difference here. Okay. One way ANOVA pula is we are looking at analysis of variance in which there are only one independent variable. Selama ini, in the previous slide, we are looking at t-test, we are looking at correlation. What else we look at? T-test and chi-square. All of these have multiple independent. Tapi semuanya pointing to one dependent. Yang ini, ANOVA ni, one way ni cuma ada satu independent, satu dependent. That means satu straight line. Okay, satu straight line saja. If that is the case, then you have to do a one-way ANOVA test. Yang Z-test ni pula jarang orang buat. Saya pun, ada orang buat. Actually, I'm not so good at this Z-test. But I'll explain it on theory lah. But if you ask me more than that, because I've not done this Z-test before, if you come across this later in your study ke apa, and if you need help, let me know. I'll find some people to help you. Because I've not done the study and I'm not sure lah of this. Okay, but basically what it's trying to do, it calculates the probability of two samples could have drawn from the same population of the same mean. Okay, so what you're trying to do is you're comparing between two sample. Okay, two sample and the means of two sample basically. Okay, two sample basically. I'm so sorry, but I cannot explain more than this because I've not done this yet lah. Okay, but you're trying to compare the means of both. Kenapa kita nak compare means of both ni? Why are we doing it the same? Why are we? That means you compare macam ni lah. Purata student di kursus yang sama di negeri A and negeri B. Okay, di negeri A dan negeri B. So you want to compare this. Okay, because we want to find out adakah ada student daripada sini, daripada population ini termasuk dalam population ini ke tak. Okay, yang ini, this is talking about simple regression. Hold on, just give me a minute. Just give me a minute. Okay, sorry. Okay, all right. Okay, simple regression means you are looking at two variables. Okay, two variables, kiri dengan kanan, x and y. Okay, and you want to do, when you talk about regression masuk R, kita nak tengok perubahan on the left adakah akan efek perubahan on the right. Perubahan on X would it affect the perubahan on Y. Macam example saya bagi kat pokok tadi lah. Tuang air is a change, independent variable. So the more kita tuang air, adakah pokok akan naik lagi tinggi. Okay. So in quantitative research, you are going to do on regression analysis. Memang you akan buat. But whether you are going to do ANOVA, t-test, itu berbeza. Okay. So simple regression only talks about the relationship between one independent and one dependent. Satu lawan satu. Okay. That's why kalau kita tengok point number 2, to determine the change in the value of dependent variable when the independent variable changes. Kalau independent itu berubah. Situ. Berubah maksud macam mana? Naik, turun. Naik, turun. Okay. And last for today is what we talk about, the hypothesis analysis, hypothesis testing. Okay. So before you do your hypothesis testing, you must always determine type 1 or type 2 error. Make sure you don't do that. Okay. Let's look at example number 1. The trail of accused criminal. So criminal ni bila kita tangkap orang tu, he could be guilty. Okay. But he did not commit the crime. So dia kita tangkap, memang kita tangkap penjenayah tu, but he did not commit that crime. So he is in a type 1 error. He is false positive. Or he could be penjenayah and he did what he is supposed to do. So he becomes a commit, so he is true. Or he is not guilty and he did not commit the crime. Okay, he is true. Or he is not guilty and he did commit the crime. Maksud dia, he committed the crime, tapi the court found him not guilty. So it's also false. So why am I saying all this? Because in a type 1, type 2 error, when you do your research, you might get the answer selain pada p-value not significant, yang tadi tu, in the previous slide, we could get this as well. That means benda tu tak betul sebenarnya, tapi you find it betul. It could be depending on other situation. Contohnya tadi, masuk air pokok tinggi. Itu yang kita tahu. Masuk air pokok tinggi, masuk air pokok tinggi, masuk air pokok tinggi. Tetapi it could be because of other reasons. It could be because of masuk air plus baja. Baru jadi sebenarnya. Tapi we only found out one je. Or we say that budak, we study the student performance online. Okay. We find out that their performance is very good. Semua dapat A. But can we conclude that it's because of they like learning online? But rupanya diorang tiru kat belakang. Ada benda lain yang kita tak study. Okay. So it could be an error as well. So we have to make sure we do not come down to type 1 and type 2 error kat situ. Because if we come down to type 1 and type 2 error, meaning the result is wrong. Maksudnya result tu salah langsung lah, totally wrong. Okay, alright, that's all for today. And last but not least is the summary, what we have done. Okay, what we have done. So if you are looking at 2 independent variables, these are the tests that you can do. If you are looking at paired variables, okay, 2, 3, then these are the types of analysis you can do. Based on the nominal or ordinal data type. Okay, that's all for today. Any questions, Ibu and Sharim? Ada soalan? Can you all hear me?